Hello everyone, I'm Lishi from Warm Cloud, and this presentation is actually collaborated by JGU or Mainz University and DDN and Warm Cloud. So we'd like to talk about QoS a little bit today. So the reason why we want to do that is because we find QoS is very important for the end users of Lustre, because for example the ls command, when we do the command on Lustre, we are expecting a very quick response from Lustre, right? Otherwise the user experience will be very bad. And also we have seen a lot of applications which has a very fixed timeout. So if the latency of the I/O is very high, then these applications will have problems when running on Lustre. And also we have seen some applications which will save data in a very consistent and continuous I/O rate, and Lustre needs to provide a guaranteed performance for those kind of applications. So we have been working on this actually for a couple of years, and we have implemented TPF and keeping on improve that for this kind of QoS purpose. We have defined different kind of TPF types, including a lot of IDs, including UID, GID, and OP code, and we can define a very complex rules based on these IDs. And we are keeping on adding new features into this framework. For example, the HTC strategy for the high priority applications. And so Mainz and GDN work together, and we summarize all of this work together, and we write a paper for that, and that paper is accepted by the supercomputer conference of last year. And because of these things we have done, we introduced to our users, and users are actually starting to use that. And the most common use case is to prevent congestion of Lustre by using TPF. So the congestion of Lustre is not happening so frequently like before. It has been improved, right? But it still happens. So we have seen users use TPF to throttle the whole rate of the system, so there will be no congestion on the MDTs. And we'd like to introduce those kind of things to everyone, so maybe it will be helpful for other users. And as a technical background, TPF has a very simple idea. So there is a queue waiting here. So whenever you dequeue a request from this queue, you will need a token for that. And the token arrives into a bucket in a given rate. You can configure the rate of the tokens. And by controlling the rate, you will be able to control how quickly the request will be handled in this queue. And in Lustre, we implement similar things, right? Because we separate RPCs into different classification, and each classification is mapped into a token bucket, and you can specify how many RP rates will be for each token bucket. And by controlling this rate and define different rules, you will be able to throttle the RPC rates of different types of RPC. But obviously, we will see some some limitations of this TPF framework. The one major limitation is that it cannot do global management. We can control a single OST or MDT. We can throttle the I/O rates on each single service node, but we are not able to enforce a global control. We need a global management for that. TPF itself cannot provide that. And also, TBF can throttle I/O performance, but it cannot guarantee performance, right? Because it only limits the RPC rates. It cannot guarantee the handling rate of each request. And also, TBF itself can only control the RPC rate. It not control the bundlewise or IOPS directly. So it's kind of mapping from the RPC rate to the bundlewise or IOPS, but the mapping is complex. So to summarize all of these, we need a global management system for TBF. And this system should be very simple. The interface to the users should be very simple. And it should be able to do some automatical management. So that's the current limitation. But as we can see, this work is not easy, right? Because as we can see, clients can write into a lot of OSTs, and the performance seen from the clients, the IOs will be distributed to these OSTs, right? But for the administrator, it cannot control the performance seen on the client side. It can only control the RPC rate on each PTR RPC NIS head, and in each OSS, you have a different surface partition, and each partition have a regular NIS head and high priority NIS head. And what the administrator can control is the IO rate, is the RPC rate on each NIS head. And in order to map in the performance seen by the client and the RPC rate, it's very complex, so it is not easy to do that. That's why we want to do more things on this. And we have been thinking about this for a long time, so we are thinking, we think what is needed for a better QoS of Lustre. So, so the first thing we need is, of course, some basic mechanisms inside the Lustre, right? So TBF is part of it, and we are thinking about other QoS mechanisms inside the Lustre. For example, we want to some kind of QoS policy which will control the stripe of the object, where the object will allocated, right? And this policy should be able to controlled by external tools, by global control tools, something like that. And also we are thinking about client-side QoS. It is useful when you want to balance the performance of different jobs on a single client. And these are the basic mechanisms inside Lustre. And another thing we need for a better QoS system is that we need a performance monitoring system. We need that to analyze the IO patterns, and we need that to get the statistics of the whole file system. We need to know more about how performance is in the whole file system. And also, we need a centralized management framework. This framework needs to control the TBF configuration. It needs to analyze the statistics from the database, from the monitoring system. And it needs to enforce consistent policy across the whole file system, right? It needs to make sure the whole file system behaves like a single person, not with different opinions. And also, we need a little bit of collaboration from the end users. We need to encourage the end users to optimize our applications. And well, sometimes it happens that the application is not well written, and the behavior is really bad, and it will cause congestion to the whole file system. And for this kind of behavior, we need some kind of penalty. And so that this application will be killed or optimized. And another thing we want to provide is to enable the administrator to set different priority to different applications, because while some users or applications have higher priority than others. So that's the reason why I implement a framework for that, and that framework is open source. You can download and check how it is implemented. And we have implemented a monitoring system. And one of the important things of the monitoring system is a collector of Lustre. And it can collect a lot of statistics from different versions of Lustre. And we store this data into a time series database. There are a lot of options for that. And we choose InfluxDB for this purpose because, well, the reason is it is very simple to use InfluxDB and the performance is good enough. And we use Grafana as a GUI framework. And Grafana is flexible, is powerful, and it is enough for this kind of use case. And also, we implement a system-wide management framework. By using that framework, we will be able to run any kind of commands on any node in the whole on the whole system, and we can get the result. And that's what the framework do. And we define different QoS policies for different QoS purpose. So here is a framework of this. So it's kind of ambitious, right? We want to provide a very simplified interface to the end users, most likely some kind of GUI interface. And we want to have some very smart algorithms, maybe integrated with AI if possible. And we want to have some input from the jobs or job scheduler. We want to know the I/O patterns of the job so we can schedule the performance of the system. And we want to integrate with job scheduler. We want to manage the TBF configuration in the whole file system. And at the same time, we get feedback by checking the performance statistics from the performance monitoring system. But in order to implement this, we implement another mechanism for Lustre. So it is called the QoS warning message on client. The idea is simple. Whenever we enforce a TPF policy on the server side, we want to print some notifications to the users TTY if they are throttled by that TPF rule. We think that is useful because sometimes users do not have any information about why the application is slow. It might be slow because Lustre is slow, but it might be slow because TBF is throttling the RPC rate, right? So we want to show more information to the users so they can know what's going on and make decisions based on that. So there are some examples of the messages, and it tells you why you are throttled, but what rules is throttling your RPC rate, and of course it is a patch of Lustre, so we push to the community. And also based on these things, we implement some policies. One simple policy is the decay policy. And in this policy, a concept is the time period. So the time period could be 24 hours usually, and you can set it to 1 hour, 1 week, or even one month if you want. And during this period, the I/O performance will be recorded for all the users, and there will be some limitations of how many I/Os you can do for each user. And if that limitations is reached, there will be some penalty. There will be some TBF limitations enforced on the system. And at the same time, because of the QoS warning messages, the users will get some notification from the consoles of the application. And of course, we can extend this into a form that is similar to the inode or capacity quota, right? We can add hardware limitations and soft limitation. So if you reach soft limitation, maybe the TBF limitation is not so strict. But if you reach hard limitation, the TBF rules will be very strict, and you can only do a very very small, very slow IOs. So this is the example of how you configure the decay policy. You need to configure and install the monitoring system, and you need to input how long the QoS time period should be, and you can set the throttles of the IOs, and you can set the TBF limitation you want to enforce if these throttles has been reached. And for each different users, you can set different throttles and for different priorities. So here is some result of that. So you can see the time period is 10 minutes, and we definitely see some circles in the performance, right? But the application is simple. It is only writing to the disk with consistently. And as we can see, we have some limitation of the throughput of this application. So when the application reached the limitation of the throughput, there will be some TBF rule set for these rules for this user, and the user will only see a very slow performance. And but at the beginning of the next time period of this TBF limitation will be removed, and the performance will go back. So here is an example of how things will go if you have two users which has the same application which is writing to the Lustre file system, but they have different performance, right? Because they are running on different clients, and as we can see, we have different thresholds for different users. User root has higher priority, so it has more credit to write more, and these two users has different TBF rules. And because of this, the performance when they are being throttled are different, but they are not affected by each other. So here is the result for the MDT performance. It's similar idea, right? The time period is 10 seconds, and at the start of time period, there is no TBF limitation, and when you go over the limitation of IOPS, the performance will be decreased by the TBF limitation. And here is the result of two users running together. The result is similar. As we can see, decay policy is very simple, right? But we think it is very it looks good because simple is good. It's very easy for us to configure with proper options, which is suitable for the file system we are using, and I think it is comprehensible because it is very similar to the semantics of inode or capacity quota, and the consequence of exceeding the limitation is very clear. If you write too much, you will have penalty. The performance will drop dramatically, and the dependency on the file system performance is very little. And also, there is no limitations of the applications, how they are going to use these bundle-wise or IOPS limitations. They can use all of the credit in 1 minute, or they can use them step by step during the whole time period. So it is easy to write application, right? And at the same time, it is easy for the users to react. So if a user exceeds his limitation, what he can do is to remove any kind of unnecessary I/O, and it should help to eventually avoid exceeding the quota. And also, if some users do not write too much data, they will not be impacted at all, and that's a good aspect of the policy. So of course we want to define other policies, right? But we have some strategy when doing that. First thing is that we want to solve a problem at one time. We don't want to mix all of these problems together. And also we want these policies to work together. We don't want to define a lot of policies that conflict with each other. So here is some potential policies. For example, we want to define a policy so to make sure there will not be a lot of burst I/O. So when a burst I/O happens, it might cause some congestion to the whole file system. So we want to prevent that. In order to prevent that, we want to enforce some penalty for it. That means we will enforce some kind of TBF limitation to the users, and we release it after a few minutes or so. And another policy we want to define is congestion control policy for MDT. So we want to use LS as a very simple but useful indicator of congestion. If LS is doing fine, we think that the congestion is not happening. But if the LS command is very slow, then it might mean congestion is happening in the file system. And in order to eliminate the effect of OSTs, we created a lot of objects with no OST object on MDT, and we LS those files, and we get a very good estimation of the congestion condition in the MDT, and we can throttle all the other RPCs except LDL in Q RPC, and we think by doing that, we will be able to define a good policy to prevent congestion. Another thing we want to do is do the similar thing for the OST, right? We want to use LS as the indicator of congestion, but we need to do more work on this because we want to accelerate the problem. So what a thing we need to do is to add a new RPC type. The RPC needs to get information from MDT. Instead, it will directly list the attribute of the objects on OST, and we can calculate how much time it will cost, and to determine whether there is any congestion happening to the OST. Including these new policies, we want to do more things for this framework. We want to test these policies, and we want to optimize these policies. And these policies should work well on a lot of conditions. And also, we have proposed implementation of client-side QoS. It's less critical than the server-side QoS, but if you run multiple jobs on a single client, you will see effect between different users. So if we want to balance the performance on a single client, we will need a client-side QoS. And also, we want to implement some kind of policy on the MDT, so it will be able to enable us to control the object allocation on the MDT. and we want to use Lime, the framework, to control the policy to achieve some kind of QoS goals. And also, we have pushed a patch which will enable us to determine which files to put into our OST pool. And by using that, you will be able to control which files will be allocated into which OST. And it is very useful if you have storage tiering with different storage types. For example, SSD pools for cache, something like that. And it would be nice if we can control the policy in a global framework. So that's all. Thank you. Any questions?
I have a questions about working this QoS in a shared file environment. All you examples have work with dedicated file per ruler. So if you have one file which can share it between different clients, and this file can be subject of different roles, you can hit a situation when different client want data which trolled by different ruler on different client. It can cause client evictions because server don't know about how much time it need to be processed, and log will be not updated long time. How it will be planned to avoid?
So, sorry, can you?
Okay, if you have some job have delayed due limit, you should have limit log cancel flash. So if different client will same data, so it will be suit a log flash on different client, but it can be delayed due to this rule. Server don't know about this, but server want an log refresh after some time. If log don't be refreshed in this time frame, client will be evicted. How it planned to avoid?
Well, I think it depends on which kind of policy we want to enforce, right? So, and for example, for the decay policy, we only limited the Intel throughput or Intel IOPS you can use with normal performance expectation, right? If you do not exceed that, no matter you will flash it doesn't matter actually how you are going to flash that. You might flash the data much slower than before because you are exceeding the quota.
You should be need something. You should be need something like a burst in some time to avoid this, as this data is high priority for a server, or you should be any way to drop any limit for high priority data. But it can be caused bad work if you have a shared file access in command workload.
So you mean different users sharing the same file?
Yes, like one client have write and first part of this file, second client word after some offset, third client have written more. Like some parts on same file will be write by different clients.
So if multiple users are sharing the same file, well, yes, it will be complex to say which IO belongs to this user, but I think the current framework will be distinguish the IOs, which IOs comes from which client or comes from which user, and it will accumulate this usage of the performance into that user. So that means it doesn't matter whether you write into the shared file or a single file. It will be it will be put into the account of that user anyway.
Thank you. Other questions?
My name is Shinichi Muto from Shizu. I have a question. Such kind of some control scheme, I understand it is very important. However, do you have any idea for what kind of fairness of accessing a file system? And to realize such kind of, for example, some use case, to realize such kind of use case, how, for example, such kind of policy is needed. So, I can't understand maybe such kind of thing. So, do you have some idea or something to implement how fairness I think that? For example, single user access or striping access. In that case, what kind of policy needed? So we can understand such kind of policy is needed.
I'm sorry. So you mean that the guarantee of the performance or?
How do you think about some fairness? Maybe QoS is
Fairness, right?
yes.
Okay, so actually, how to say, we have a lot of potentials by using this framework. If you only want some very fair policies between different users, and you can define that, right? Every user have the same limitation. They can only use, for example, 100 gigabytes per second. They can only write 100 gigabytes for 25 hours, and everyone has that limitation, and that's kind of fair. And if you exceed that limitation, you will have penalty. The performance will be very slow for you for some time until the next period, right? But you are free to use you are free to allocate it how you use these 100 gigabytes, right?
So you are only providing framework. So such kind of fairness is I think of some users, some frameworks can be have to be considered. Right here, in my understanding.
Yes. So we are collecting different use cases of this, and it's difficult to know what would be the best best policy for different use cases, and we need to know about the expectation from the end users, right?
Thank you, Richie.